Hello everyone, the tech teacher here. Today we're going to go through an interesting LeetCode problem, which is a pretty famous problem in top companies. It's called clone graph. Personally, I was asked this problem before in 2017 when I was applying for an internship at a FANG company, and at that time I got rejected because of my solution to this problem. So let's jump right in. The problem is talking about a connected undirected graph, and the requirements are to deep copy or deep clone the graph. Each node in the graph has a value, which is an integer value, as well as a list of neighbors to this node. So taking this as an example, if we have this graph 1, 2, 3, 4, we should return a new graph that have the same structure but with newly created nodes like 1 dash 2 dash 3 dash 4 dash. And this problem during the implementation, it can be quite tricky, but it can also be very easy. And the key to this is that the most important way is to find a way from every node in the initial graph to get the corresponding node in the newly created graph. So for this specific purpose, we should use this node, which is each node's value is the same as the node's index, one indexed. For example, the first node with value equal 1, the second node value equal 2, and so on. So this means that we can basically assume that the node's value is a unique ID for every node. This can be the key to the map to get from a node in the initial graph to a node in the newly created graph. Here we have this example and another very simple example with a single node like this. Let's start with our implementation. So as I mentioned, we should start first by having a data structure that maps between an ID of the initial node to the newly created node in the new graph, like this, which is a map of integer because our value here is an integer, and of integer to node, like this. And then when we finish our code, then since the requirement is to return a pointer to the clone of the provided node here, so we should return something like return map.get node.val, right, like this, which is the cloned node of the provided node. Let's add our check here for null. If node equal null, then we should return null, meaning that we don't have any graph. That's nice. Then back to the core of our problem here. So the idea here is to traverse the initial graph, and while traversing the graph, we should copy or deep copy the nodes and the edges into our newly created graph. So this can be done using either DFS or BFS. Both will work. For me, I would prefer for this problem DFS because I find it easier in the implementation, but it can also be done using BFS. Let's start by implementing our DFS. So we are going to call the DFS. So as you know, DFS is done usually using either a stack or a recursion. I'm gonna be implementing it using a recursion. So I will call DFS from the current node and will pass the map as well. Now let's write our DFS method, which will take two parameters, the node and the map. and it will be void for sure, like this, right? Then we should, for every method here, for the dfs, we should make sure that every node in the initial graph or the dfs method is called only once for every node in the initial graph, because we're gonna clone the node here first by creating a new node, which is cloned one, and it should have the same value as the initial one using this constructor. Then we are going to add this node to our map. The key, as we agreed upon, will be the value, and the value for this would be the clone node, right? Then we should visit the neighbors, and we should also clone the edges. And this is done using looping first over the neighbor node, call it next, in node dot neighbors. So for every neighbor node in our current node, we should check first if it was visited before or not. So we should clone the current edge, right? And then we should visit it if not visited before, right? How are we gonna check if it wasn't visited before? So this by using our map. So if not map that contains key next dot value, this means that the next node is not visited, because if it was visited before, then the map should contain its clone. So if it wasn't visited before, I will go and call dfs with the next node and the map, right? And that's it. Now let's clone the current edge, which is the edge between the node and the next. So basically this will be done using, I would say, map.get node.value, which is the clone for the current node, dot neighbors dot add. So I need to add the clone of the next node, which is map.get next.value. So it's pretty easy here. But what we're doing is that creating a map first, and then starting a DFS from the initial node with the map. With every DFS call, we clone the node and we add the clone to the map with the same ID. And then for every neighbor to this node, if this neighbor wasn't visited before, I'm gonna simply visit it. And then I am going to copy the edge that I'm currently on, which is map.get node.value, the clone for the current node, .neighbors.add, the clone for the neighbor node. Let's run this to check how it goes. Interesting, so it got accepted. Now let's submit it. Yep, hooray, so yeah, it got accepted. I think that's it for today's video. If you like the problem, the solution, drop me a like and subscribe to the channel to encourage us to continue. Feel free to share the video as well, and I'll see you in the next problem.